14, we're starting on the case study page, so 301, and you should be able to briefly explain how mountaintop removal mining or mountaintop mining works. So this is what the mountaintop looks like originally, and there's coal underneath the mountain. So with mountaintop removal mining, they first clear all of the forest off, and they get rid of that, and then they scrape off or explode away the rock that's on top of the coal to get down to the coal layers. So they're getting to the coal here. They'll probably blow off what's underneath that after they get all the coal, and then get to the coal there. So this displaces a lot of soil and a lot of sediment. Once you take all of the trees off, then that means erosion is very likely to happen, so flooding is possible. Mudslides are very common. So one of the things you should be able to talk about are environmental and economic impacts. Coal, as you guys know, is a cheap form of energy, but a lot of other things have gone down in price. So gas was one of those that's gotten cheaper. So a lot of coal plants and coal companies have actually gone bankrupt. A bunch of mines have closed because they're just not producing coal anymore. There's no more coal for them to mine. A difference between mountaintop removal mining and traditional mining. Traditional mining would involve digging tunnels and sending workers in to carve out the coal kind of by hand. And mountaintop removal mining doesn't provide as many jobs for the community because you're using explosives and blasting it away, as opposed to having people dig it out by hand in mine shafts. Environmental impacts, all of the water that's created, the wastewater has to be stored. It can't be dumped into a river, so you have huge storage facilities, and those have collapsed in the past. And when they collapse, it completely floods the town or the nearby area, and pretty much means people have to move. There's not really much going back after that happens. So that's a huge impact for them. Looking at 14.1 proper. So we're talking about the earth and all the stuff inside the earth. So you need to know the layers of the earth. So there's the crust on the outside, then there's the mantle, and then there's the core. So the core is thought to be liquid or semi-solid in the outer core, and the inner core is supposed to be solid. The mantle is what would contain what we would call magma. Do you know the difference between magma and lava? And lava is generally what we call it once it comes above ground. So magma is considered to be under the ground. That'd be a good thing just to know the difference between terminology.
So above ground, magma is below ground.
Yeah, pretty much. Okay. So the layers of the earth, I feel like you probably knew those already. Okay, so hopefully that feels like review. You probably don't know the difference between oceanic crust and continental crust at this point, though. So you do need to know that. One of the biggest differences is that the oceanic crust is thinner and it's younger, because most of the faults, most of the boundaries between different tectonic plates are in the ocean, so they are constantly being broken up and reformed. So that's younger rock, it's newer rock. That's also one reason why it's thinner. The continental crust tends to be thicker, it is older, and there's some difference in what types of rocks are in the oceanic crust versus continental crust. You really just need to know kind of the brief difference in age, though, and the thickness versus thinness, okay? So if we were talking about a volcano that was going to form in the middle of the U.S., that's way more unlikely than volcanoes forming in the middle of the ocean because of the difference in the crust thickness. That's one reason why we see most volcanoes in the ocean. Another big reason is the different kinds of faults and boundaries, so we'll talk about those, okay? Next page, look at the beautiful, beautiful, beautiful map. We're gonna make a map kind of something like this, just so that you get some practice with geography and latitude versus longitude. So that's one of the things you should know. What's latitude versus longitude? Anybody wanna tell me now?
Latitude, longitude.
Okay, latitude, longitude, yeah, you should know those. Okay, so latitude is horizontal, longitude is vertical. So you should be able to talk about why the tectonic plates move. and this is because of currents in the mantle. So because the mantle is largely liquid, because it has a lot of magma, as heat from the core heats up parts of the mantle, and then that moves, that creates current inside the mantle. So that's why tectonic plates shift and move around. You need to know that. Look, magma. See, magma is molten rock. Okay. You need to know some terms like subduction or subducted, mid-ocean ridges. You need to know what that is. We will come back and talk more about the different types of boundaries. So there's divergent, convergent, and then transform plate boundaries. We will talk about those because that's not in this part of the book. I don't even think it's in this book. So I'll get to supplement and I'll show a video and we'll talk about it, that kind of thing. Okay. You should know what the Ring of Fire is. So, and it's not the Ring of Fire that's in like that song.
Johnny Cash.
Yeah, Cash song. I couldn't remember who it was, so I wasn't gonna say.
It's volcanoes.
Yes, it's primarily volcanoes. So this is something. If you look at the Pacific Ocean, the Ring of Fire is around the Pacific Ocean. So it includes Indonesia to Japan to Alaska, and down the west coast of the U.S. So think Seattle, California. Okay, and that's where ocean plates are being subducted under the continental plates. So that's where we get a lot of earthquake and volcanic activity because of the tectonic plates. We will talk more about earthquakes as well. That's also not something that, as far as I'm aware, is really in this chapter. So I'll supplement for that. But you'll need to know what the Richter scale is, kind of what a seismograph is, and some other earthquake-related terms. But that's not something you have to know from here because it's not in the book. So you can't take notes on it. Moving on, you should know the rock cycle. Okay, so what are the different types of rock?
Mineral.
No, there's three main groups of rocks.
Igneous
So igneous rock, yep, igneous, sedimentary, metamorphic. Notice that's on this page. Ta-da! See? So you should be able to talk about what gets us from one type of rock to the next. Okay? So sedimentary rock, metamorphic rock, igneous rock. So igneous rock requires a lot of high temperature and a lot of pressure. In order to go from igneous rock to sedimentary rock, there's weathering and sedimentation. Here's a fun word, lithification. Okay, so these are terms that when you read these couple pages, you'll hear about them. But the difference between minerals and rocks and ores, I didn't know this until very recently. A mineral is something that we mine in order to get metal. So ores contain minerals. Minerals contain metals. So we would mine for a specific type of mineral so that we can then extract metal from it. Or we mine for a specific type of ore so that we can extract metal from it. So then when we're talking about just rocks in general, rocks are a mixture of different types of ores or different types of minerals. So we kind of go from rocks just in general as a bigger category to specifically minerals or ores to specifically types of metal. It's kind of the flow of thought or organization if we're talking about different terminology. Okay. This is a good example, this figure 14.4, of how the tectonic plates work. So subduction is where one plate is going underneath the crust, okay, and then you get trenches along that place where they're splitting apart. That you get an ocean ridge, so that's usually where magma can come up. Active volcanoes are also going to be where the subduction is occurring, so you see volcanoes in multiple places. Okay. So when we're talking about the rock cycle and different kinds of rocks, this is something that you'll see. You're really not going to ever get questions about these different time zones, though. How long ago they were, what order they were in. The biggest question you might get is from a period that's not even listed here, right here in this example. It's called the Carboniferous period. And it's called that because that's when a lot of carbon was absorbed by plants from the atmosphere and then all of those plants got buried. So that's when our fossil fuels were kind of created, if you want to think of it that way, because that's when all of those plants got buried. So you don't have to know this or this order. I will not ask you a question about it. Okay, you shouldn't see a question about it. So don't worry about trying to memorize that. When we're talking about rock, what is weathering? Do you know?
Isn't that like, it's not like chemical, but it's like physical stuff happens to the rocks?
Yeah, it's there's different types of weathering. So it can be chemical, or it can be like physical breakdown of the rocks. So if you own the same set of concrete steps at your house for 20 years, pieces of it are probably going to break off in that 20 years time. We go another 20 years, more of it's going to break off. That would be mechanical weathering of the concrete or of that stone piece. So sedimentary rocks are formed by different types of weathering. So it can either be breaking down chemically or mechanically. So some things that can accelerate weathering include acid rain. Erosion can increase weathering as well, so erosion or acid rain. But once those rocks are broken down, then sedimentation is the idea of the rock pieces being carried somewhere and then kind of dropped off. So sedimentation occurs at the mouths of rivers, or the mouth, not the head, so the end of the river, where rocks that are carried downstream kind of get deposited and left, so that can build up. That's sedimentation. Okay. So really short section, not a whole lot that you need to know, but most of what you need is primarily different terms, I think.